All right, so now we're up to talking about simple interest. So you've probably done simple interest to death since year 9, so we're going to very quickly go over it, but we're also going to make the link back to patterns and sequences, which we did before. So put it very simply, interest, which is calculated on the original amount. So I invest or borrow $500. The interest that I have to pay is as a percentage of that amount over however many years I am going to be paying it off. Okay, so we have a formula which we can use to express that, which is I equals P times R times T. And this bit is just calculating whatever that interest is. And then the T here is just how many years over, how many years we're going to be paying it off. So it's a pretty simple formula. Now this interest rate, we usually express as P dot A, which means per annum. But if we are maybe calculating interest on months or even days or weeks, we would need to change this to the corresponding interest rate. So we need to divide it by 12 if we're looking at months, by 52 if we're looking at weeks, and 365 if we're looking at days. Now, you may also see it written as I equals PRN over 100, and it really is just the same formula, because this bit here, oops, not that bit, this bit, the R and the 100, all that is just converting the R, which is the interest rate, into from a percentage, so dividing it by 100. If you use this formula, you need to do that yourself. The N here just represents the time period again, and they use N because it could either be years, months, or days, or something like that. And then P is the principal as before. So we can connect this with sequences. So I've got a new form of the formula here where this A represents the value or the amount of the loan or investment. And all it is whatever our principal is, plus the interest bit here. Now, we have our rule that we looked at before for the nth term of any sequence, and just so you know, we're using n, not n minus 1, because we're using v0, not v1 as our initial term. Okay, so let's connect this formula to the simple interest formula. So this A here represents Vn, which is just the value at some point. This P here is the initial term, which is the A. And then this PR, that is the common difference. So that's just finding the percentage of the principal, which is the interest. So that's the common difference there. And then this T just represents the N, so whatever term we are in the sequence. All right, so let's have a look at a very quick example. We've already really done a couple of these already. So calculate the amount owed on a simple interest loan of $16,000 at 8% per annum after 2 years. Okay, so first step is to find 16% of, 8% of 16,000, which is that bit there, and then multiply it by the number of times the time that we're owing. So that equals 2560. Now when it refers to the total amount owed, we not only have to pay back the interest, but also the original amount we borrowed. So we can represent them with A, and that is just the principal and the interest added. Pretty straightforward. Now if I wanted to do that in a recursion way, I would find the common difference, which is just this first bit, finding 8% of 16,000, which is 1,280. And then I would use the nth term rule. So we're finding V2 because we're after 2 years. So V0 is the initial term, V1 is the first year, V2 is the second year. That's why we use V0. And this is 16,000 plus that 2 times the common difference, which gives us 18,560, which is what we got above. right, so we may be interested in finding the other values, so not just the interest, but maybe also the interest rate. So what I want you to do is I want you to take the formula, have a go at this yourself, practice your rearranging, and rearrange it so that we make R the subject, or we're trying to find R. Okay, so R, we're going to divide both sides by PR, so we're left with PT divided by PT. Now do the same for T, and do the same for P. Okay, they're all pretty much got a very similar form. It's going to be time is equal to I divided by whatever's left, so P and then R. And then here we've got P is equal to I divided by R and T. Now just note that when you calculate, say, R in this form here, you need to multiply it by 100 to express it as a percentage. Now, you may have been told in the past that simple interest is not really used. Well, it kind of is. So, whenever you store money in a bank account, an electronic bank account, and it's a savings account as well, the bank will pay you interest. So essentially investing money in the bank. And the reason why they'll pay you is because the bank wants money so that they can loan out to people for houses or credit cards and stuff like that. So they pay customers to store money with the bank so that they can use that money to loan out to people. You still have your money, the bank still owes you that, but they're giving you the interest back as, an incentive for people to actually store money in their bank account. Otherwise, people would just store money in cash. But they don't. But when they calculate the interest, they don't calculate the interest on the balance at the end of the month. Instead, they actually calculate it on the minimum monthly balance. So let's have a look at this table here, which shows the entries of a guy named Tom, his bank account. So at the start of June 30 here. So here, pay and credit just means that that's the amount of money that's in his bank account at the time, okay? Now, debit means that he's taking away $50 from that $400, so he's down to $350, and that happens on the 3rd of July. And then on the 15th of July, he's adding $100 to his bank account, and then that's his balance at the beginning of August. So what is the minimum monthly balance for July? That would be $350. And this is the amount that we use to calculate the interest, not the $450, okay? So that's why it's not a great idea to take money out of your savings account, at least a large sum of money, because when the bank calculates the interest, it's going to calculate the interest not on the amount that's at the end, but actually what was the lowest amount throughout the month, okay? So if you start off with $350, then maybe you put in $450, and then by the end of the month, say you have $600 there, it's still only going to calculate the interest on the $350. It's a bit of a sneaky one the banks do. So it's just simple interest, and it's only for 1 month, so we need to do it once, but there's an extra step that we need to do. We need to convert this 3% per annum into a monthly interest rate. So 3 divided by 12 is a quarter, so that's 0.25% per month. Okay, so then we calculate the interest. And T is just 1 because we're doing it once, so over 1 month. And then that's 350 times over 100. And that gives us 88 cents. So you don't generally get that much. And most banks will pay you, I think 3% is a bit high at the moment. I think it's somewhere between 1 and 2% is the interest rate on savings accounts. All right, so just a quick summary. Simple interest, we've seen it before. It's just interest calculated on the original amount as a percentage of that original amount and then added on. We express the interest rate usually as per annum, but you may need to change it to per month or per day depending on when we're calculating the interest. then we connected it with sequences. So the formula put into this form here is pretty much the same as the nth term of any sequence. Looked at an example there, found other values, and looked at this idea of the minimum monthly balance, which is in a savings account. The interest that the bank pays you is only paid on the minimum amount during that month, not on the balance at the end of the month.